after a rotation of 70 degrees counterclockwise about the origin. About the origin. So you're rotating 70 degrees counterclockwise, and we're going about the origin. So I'm going to draw a little picture here. And this is like we'll go a little bit harder than this, but we're not going to go into too much depth with these. So point A is 3, 0. Call that right here, point A. And we're rotating. Now remember, you're rotating, you're staying the same distance away. So you're rotating like in a circle, because a circle is always the same distance from the center. So your center of rotation is like the center of a circle, and you're rotating around the outside. So we're going to rotate to a certain point. 1, 2, 3, 2, 3 up here. We're going to rotate to a certain point, and that'll be A prime. Now A prime is going to end up being the same distance from P as A. So A prime is going to be the same distance from P as A, and the distance from A to P, or P to A, is 3. So I draw a little triangle here. The distance from P to A prime is going to be the same distance as P to A, which we just said was 3. Now, we know the distance from P to A. We can take point A. We have a distance here. And if we break it into its x and y components, here, if we make a little right triangle here, that's going to give us our y and our x, which will be the coordinates of point A. And we were told that rotating from A to A prime, if we look over here, was 70 degrees. So that's this angle right here, 70 degrees. And here's where that trig is going to come in. So to find out your y component, well, the sine of 70, so the sine of 70 is equal to the opposite over the hypotenuse. So 3 sine 70 equals y. When you calculate that, I pre-calculated, you can round off, and you actually end up rounding to 1 if you round to the nearest tenth. So the y coordinate will say is 1. And then we're going to have our x coordinate here, and we are going to go and do cosine of 70. So cosine of 70, we will end up with, so we're going to do adjacent over your hypotenuse, so x over 3. So 3 cosine of 70 equals your x value. So when you do 3 cosine of 70, you should get x is equal to your 2.8 there. And let's see, I'm going to double check myself. 70. Oh, sorry, my pre-calculations were written backwards. That was confusing. Your y should be 2.8 and your x should be 1. I apologize there. It wasn't adding up to me. So y should be 2.8, and x, when you round, would end up being 1. And then when you have your final coordinates, you're going to put your x and y together. Those numbers didn't seem right the first time, but now these seem much more accurate. So when you go ahead and graph, be roughly 1, and then 2.8, 8 prime, so you really went like right about here. These distances are going to be the same. And there we go. So your coordinates for A prime are 1, 2.8, not 2.81. That's why we have erasers, to fix mistakes. Alright, so that was our first. We'll do one more, and then I'll give you 3 to try on your own if you feel up to trying them, if you don't feel 100% comfortable. So our next one, slide number 14, we have, let's see, slide 14. It says we have coordinate h is 4, 2, and we are going to rotate it 30 degrees counterclockwise, and that's going to be about the origin. There are ways to rotate a point not about the origin. There's certain formulas you can derive, and I'm sure you'll do them when you get into some higher levels of math. Right now we just want to get a basic foundation built. So let's go ahead and make a coordinate plane here so we can see what's going on. We have point H, which is 4, 2. This is point H. And we're going to rotate that about the origin. I like calling the origin P. And we're going to rotate that 30 degrees. So it's going to rotate 30 degrees. That's a 30, believe it or not. And it's going to end up at H prime, wherever that is. Now what's different about this is we can try to make a right triangle to find the coordinates of H, but we don't have the whole angle. So one way to look at this is first we need to figure out what this angle is right down here. We'll call that angle theta, because we're going to need that part. If we add that to 30, we'll have the whole angle here, so we can make a nice little right triangle. In order to do that, well, we need to make a different right triangle. From P to H, we don't know the distance yet, but we do know this down here would be 4, this would be 2, if we made a right triangle from H, because of our X and our Y. So we can, well, first off, we can find our missing value up here at the top simply by doing a little bit of Pythagorean theorem. 16 plus 4 equals C squared. So C is radical 20, which we get 2 radical 5. So C is 2 radical 5. And now we can find this angle right here by using, we call that theta over here. So the tangent of theta would be 1/2, 2 over 4. So that means the inverse tangent, or the arctangent, I think we've been calling it inverse, so we'll stick with that. Inverse tangent of 1/2, it's going to give us theta. The inverse tangent of 1/2 gives us theta equal to 26.6. So now we have 26.6, that's this angle right here. Now if we look at point H prime, and we'll make a nice little right triangle. The whole point of finding this was to help with H prime. We have point P to point H. We can make a nice little right triangle to find your X and your Y. Here's Y, here's X. We knew part of this angle was 30. We're talking about this triangle right here. Part of the angle was 30, the other part was theta. So 26.6 plus 30 gives us 56.6. So this whole angle in the right triangle is going to be 56.6. So we have that, we have the right angle, but we need to find the two sides. In order to do that, well, we have a rotation going on. So the distance from P to H is the same distance from P to H prime. So P to H prime is 2 radical 5. And now we can use some nice trigonometry here. Some nice trig ratios. So I'm going to take away this work. I'm limited on space. We're going to say sine of 56.6 equals our opposite over our hypotenuse. And I'm going to double check my calculation this time. The last time I wrote the wrong answer. So sine of 56.6 times our 2 radical 5, and we should get 3.7. This is a y up here, not a 4. 3.7 we round to, that's our y. And then we can do cosine of 56.6 equals x over 2 root 5. So cosine of 56.6 equals that times 2 times our radical 5. And we end up with x is equal to 2.5. So that means our coordinates, or if we had this triangle, 2.5 when we round, 3.7 when we round, those would be your coordinates of h prime. 2.5, 3.7. So there we go. That's how you can use a little bit of trig to do rotations about the origin that are not increments of 90. A little bit of work, but I think it's fun. Alright, so I'm going to put, actually on the slide presentation there's 3 questions, and you can go ahead and try those 3. The answers are actually posted in the little notes section at the bottom if you want to check. I'll put a little space between them so you can check one at a time. There we go. Just scroll down in that notes section. You can check and see if you got them right. If you're having trouble with them, just leave a comment, or if I send out a Google form, leave a comment in the forum, and we can go over those. Alright guys, have fun, enjoy the math. I'll talk to you soon.